Okay, now we're now on our video on the operations of algebraic expressions. This video will be about multiplication, solely on multiplication, because there's a lot of ways to do multiplication in algebraic expressions, and we will be facing this thoroughly one by one. So this is again for college algebra. This video should be watched ideally right after the addition and subtraction video. Okay, so let's start. There's no better way to understand and know mathematics but by example. So for my first example, I'm going to show you multiplication of algebraic expressions, that is monomial by monomial. Again, monomial is just a term. It's just a single term. There's no plus or minuses between terms, so they are monomial. So in this example, we are given three monomials to multiply. So we're going to multiply them one step at a time. Okay, so when we multiply monomials by monomials, what we need to do is we need first the laws of exponents, the rule of signs, and commutative and associative laws of multiplication. So specifically, we can just combine first or multiply first the numerical coefficients and try to combine the terms, or rather the exponents of the same variable. Okay, so let's start first with the what do you call that, with the numerical coefficients, because they're much better or easier to do. 2 times minus 3 is minus 6. Minus 6 times 5 is minus 30. Let's put that as our answer already. Minus 30 is a sure answer. Okay, so we need the variables then. And we need to recall a very simple law of exponent, which is called the law of product, or product law in some books. So the product law states that if we have an x um, raised to some number a, and we will multiply this term by another x, wherein they're the same, the x and x are the same, by another number, let's call it b. So in practically, we're multiplying two terms which are like terms. I mean the same variable, not like terms technically, the same variable but different exponents. So what are we going to do is just to copy that variable, but we will be adding the exponents. Okay, so copy the variable and we will be adding the exponents. Okay, and this follows for a lot of terms also. So if there are x raised to c, x raised to d, so we just need to add plus c plus d here. Okay, so what are we going to do? Notice we're going to start with the x's first. So in this x, we can see that there's an x cubed raised to 3. And here, this x is a sole x, this is a single x. Okay, but then note, remember that every number which doesn't have any degree or an exponent is raised to 1, automatically raised to 1. So we have here an invisible 1 as an exponent. And we have here also an invisible 1 as an exponent. As an exponent. I cannot write it. Okay, let's put it as like that. Okay, so 3 plus 1 is going to give us 5. So therefore, in our final answer, this will be x raised to 5. Okay, next up in our variables is the variable y. So like the same concept with the x, we have y squared here, y raised to 2. We have also y cubed here, y raised to 3. And we have y here, a sole y, which is raised to 1, remember. Oops, sorry. Raised to 1. So we have 2 plus 3 plus 1. That's going to give us 6. So therefore, our final answer will be y raised to 6. And let's have with the last variable, z. We have here the z raised to 1. Okay. We have here x. Oh, we have another x here. Okay. So we have an x here. I think this is a, sorry, this should be z. Sorry. Kindly change this into z. Okay, my bad. Oh, okay. Also in your modules, I'm very sorry. I wrote x there. It should be z. Okay. My bad. This should be z or z. Okay, this should be z, not x. Okay. So sorry for that. And this is z raised to 1. Anyways, this is z raised to 2. Let me encircle it. So we have z raised to 1, z raised to 2, and z raised to 1. So we have 4 as our exponent. So we have z raised to 4, and this is our final answer. Minus 30, x raised to 5, y raised to 6, z raised to 4. Okay, so that's our answer if we're going to apply or multiply algebraic expressions which are all monomials. And you can repeat the process if you want to have some clearer view. Again, this is Z. I'm sorry about that. Moving on, our next example will be multiplying algebraic expressions which is polynomial by monomial. Or did I say that reversely? So monomial by polynomial. Anyways, by commutativity, it's still the same. Okay. So what are we going to do? We just, distribute this monomial, wherever the monomial is, distribute the monomial to each of the term of the polynomial. So distribute it here, um, distribute it here, and distribute it here. Okay, so by distribution, what we will have is, let me use the blue ink now, blue pen. So minus 5 times 7. So minus 5 times 7, different signs, that's going to become negative. So 5 times 7 is 35, minus 35. And then, notice here we have x cubed. Here we have x squared. So by the law of product, we are going to copy the x, but add the exponents. Remember that in the last slide. So this becomes 5. And notice in this term, there's no more variables except x. So all the variables here, the y squared and the z, just copy. Y squared z. Okay? Now, next, we're going to distribute this number. Imagine distributing this number to this number, 5x. Okay, again, multiply the numerical coefficients. Minus 5 times 5, since they don't have the same signs, they have different signs, so this becomes negative. 5 times 5 is 25. And then we have x cubed here, and then we have just simply x here. Remember, there's a 1 hidden. Okay, so we're going to copy x, and 3 plus 1 is 4. Notice also in the second term, the middle term, there's no more variables there, so we're just going to copy the y squared z. Okay, and then lastly, we're going to distribute this monomial to this last term here. This is a constant, which is minus 4. Now, multiplying this only by the constant, but this constant by the numerical coefficients, because it doesn't have any variable, which means we just need to copy this. Okay, we just need to copy this. So minus 5 times minus 4, since they have the same signs, that's going to become positive. 5 times 4 is 20. And copy the rest of the terms in the monomial, x cubed, y squared, z. Z raised to 1. Or we can just put z there. And this will be our final answer for multiplication of monomial by polynomial. Okay. Again, if you haven't, there are some questions, you may redo this video. Okay, you may rewatch, and practice this video. Okay, now lastly, in our multiplication of algebraic expressions, we're going to try now multiplication of polynomial by polynomial. So we have more than one term, more than a monomial to multiply to each other. So this is gonna be quite how shall we say, tasky, but bear with me with this. Okay, so what are we going to do? We're going to adhere with the distributive property of multiplication over addition, or simply distributive property that will do. What are we going to do is just to distribute all of these terms by all of the terms on the other side. So a very simple example is the FOIL method. So say, for example, we have two binomials. So that's a very short example. So we have, for example, x plus y, and we have another here, a plus b, and then we're going to multiply this binomial by binomial. So what will happen is the FOIL method. If you can remember the FOIL method, the FOIL method looks like this: first, outer, inner, and last. And this will be the same exact concept we're going to follow in this. So multiply this 3x to the fourth to the x, multiply this to the minus 3, multiply this, if I can, 3x to the fourth, multiply it to the x, sorry, 3x to the fourth, multiply to the x, multiply it also to the minus 3. This minus 5x cubed, multiply to the x, multiply it also to the minus 3. This 2x squared, multiply it to the x, multiply this also to the minus 3. This minus 4x, multiply this to the x, multiply this also to the minus 3. And this positive 7, multiply this by the x, and multiply this also by the minus 3. So again, this is quite tasky, but this can be done. Okay, this can be done. So bear with me here. So please be with me. Let's start this slowly. Okay, and then after doing this, after multiplying all of them, we need to combine them. Okay, and then make the simplest form. Okay, so let's start. Okay, so we have 3x to the fourth times x. Okay, so 3 times 1 is 3x. Okay, so we have a raised to 4 here. This is raised to 1. 4 plus 1 is gonna be 3x raised to 5. Okay, 3x to the fourth multiplied by minus 3. This is positive, this is negative. They have different signs. Minus 3 times 3 is 9. And we have x to the fourth. This is a constant, so simply copy x to the fourth. Okay, next up is minus 5x cubed multiplied by the x. So copy the constant or the numerical coefficient, x. Then 3 plus 1 is 4. And then minus 5x cubed times minus 3, they both have the same sign, so it's gonna become positive. 5 times 3 is 15. Okay, and then copy the x cubed, since we cannot there is no x in this constant. Next up, so we're now here, don't get confused. Okay, please bear with me, please be with me rather. Okay, 2x squared times x, so just copy the numerical coefficient. X will be the variable. 2 plus 1 is 3, that's going to be cubed. And then 2x squared times minus 3, so they have different signs, this is going to become minus. 2 times 3 is 6, and then copy the x squared since there's no variable in 3. So we're done here. Next up, move it here. Oops, sorry. 4x squared times x, so copy the minus, copy the 4 because we have 4 times 1, and then x, so x 1 plus 1, that's x squared. Okay, and then minus 4x times minus 3. So since they have the same signs, it's gonna become positive. 4 times 3 is 12, and then copy the x. Okay, lastly, what we have is 7, the 7. So 7 times x is positive 7x, and then 7 times minus 3 is minus 21. Okay, so we have this long expression. The next step that we're going to do is to simplify. So we have only one x to the fifth. There's no other like terms. There's no other term here which is raised to 5. We have here two terms which is raised to 4, x to the 4. So these are like terms. We can combine them. Here we have also two terms which are raised to 3 or cubed. We can combine them. There are also two terms which is squared or raised to 2, power of 2. There are also two terms raised to the power of 1 by x, and there's also one constant term. So we're just going to copy this since there's no other terms like this. And by our simplification thingy or method rather, sorry for the word. Okay, 3x to the fifth. Okay, minus 9, minus 5. They're both the same sign, so we're going to add them normally, copy the sign, minus. Copy the term 14x to the fourth. So plus 15 plus 2, they have the same signs, that the answer is 17. Copy their sign, positive, and copy the variable x cubed. Here we have minus 6 and minus 4, they have the same signs, that add them, that's 10, copy their signs, minus, and then put the variable, copy the variable. Also here, 12 plus 7, they have the same signs, so just add them. 12 plus 7 is 19. Copy their signs and copy their variable. And we don't have any like terms for this, so copy it. Yeah, copy it. Okay, simply copy it. And this will be our answer for this polynomial by polynomial. Hopefully you are with me when we were doing it. Okay, that's a pretty long process, but I made it clear. I made it very clear, hopefully, that you were able to follow it. Okay, step by step. Okay, all the steps, for all the steps. Okay, so again, if ever there are some problems with this example, you may rewatch and rewind. Okay, so I think that's all good for the multiplication of algebraic expressions. We have three um, types of multiplications. If you want to have it very explicitly, so we have monomial by monomial, pretty much straightforward. Monomial by polynomial, okay, what we did is simply distribute, and then polynomial by polynomial, we distributed each of the terms by each of the terms, just like this FOIL method. And that's it for our multiplication of algebraic expressions. Okay, next up in our video will be division of algebraic expressions. So, um, what do you call this? Continue, try to subscribe so that you will be notified if I already uploaded the division of algebraic expressions. And don't forget to like this video if this helped you in multiplication of algebraic expressions. So thank you very much and see you soon. Bye.